Hello guys, this is Harismata. So today we'll be mainly discussing about the formula sheets and certain definitions on differentiation and continuity. Okay, so let's quickly get into the video. So when you talk about continuity, so what is continuity? Suppose if you're having f is a function and c is a point. So a function is said to be continuous on the particular point. Okay, if it is continuous, then what can you say? Your limit extends to c minus f of x, which is your left hand limit that will be equal to your function value of the function at the particular point, which is f of c, that is equal to limit extends to c plus f of x, which is equal to your right hand limit. So that then you say it is a continuous function. For example, if it is defined for a closed interval, what you should say? So it's first thing, for that you have to check if it is defined, if it is continuous on an open interval a comma b, then you have to check limit extends to a plus f of x is equal to f of a and limit extends to b minus f of x is equal to f of a. So these are the three conditions for you to check if it is continuous in the closed interval a comma b. Okay, now differentiability. So differentiability, what do you say, what do you call, like when do you say a function is differentiable? Or yeah, so a function is differentiable if both your right hand derivative, so this is right hand derivative, left hand derivative, so minus means it is left hand derivative, so limit h tends to 0 minus f of c plus h minus f of c by h, and limit x tends to h tends to 0 plus f of c plus h minus f of c by h. These both should be finite and these both should be equal. So these are the conditions for you to check if the function is differentiable. Okay, and same way, if you are checking if it is differentiable in the closed interval a comma b, first your right hand derivative and your left hand derivative, right hand derivative at the particular point A and your left hand derivative at particular point B should exist, and then your f dash of x exists for every point in the closed interval, same way as you have seen in the continuous, but there are slight differences, that's it. And now you are seeing the theorem. So basically, if two functions are basically the properties, if two functions are continuous, how do you say? The addition of two functions is also continuous and subtraction of those two functions is also continuous. Then if you multiply a constant to a function, that resultant function is also continuous. Then if you multiply two continuous functions, that is also continuous. And when you divide two continuous function, that is continuous provided your denominator should not be equal to 0. So these are the main properties. Now these are the basic derivative formulas. So your constant rule, when you differentiate the constant, you will be equating it to 0. That will become to 0 only. And when you're multiplying a constant and when you differentiate it, so basically this will be c into f dash of x. Okay, so this is how it will be. Now power rule is nothing but x power n. When you differentiate x power n, how do you do it? N into x power n minus 1. Okay, now next is sum rule. Sum rule is when you differentiate sum of two functions, so you have to individually differentiate it. What is this? Basically it is d by dx of f of x. F dash of x is nothing but differentiated function of f of x. When you differentiate f of x, you will be getting some function that we name it as f dash of x. Likewise g dash of x. So this is nothing but your product rule. Product rule is nothing but your f of x into differentiation of g of x plus g of x into differentiation of your f of x. Now quotient rule. So when you divide the function and derivate it basically, so you will be having g of x into differentiation of f of x minus f of x into differentiation of g of x divided by g of x the whole square. Okay, now chain rule. So chain rule is basically when you differentiate it, so basically it is f dash of g of x into f dash of x. So this is the chain rule formula. Okay, now These are the basic formulas which you have to know. I have just listed few formulas. So other complicated formulas I haven't listed, but basic few formulas which you have to know, I have listed it. So when you differentiate the constant, it will be 0. E power x, when you differentiate it, it will be e power x. A power x, when you differentiate it, is a power x log a. And when you differentiate log x, it will be 1 by x. Likewise, if you differentiate root x, it will be 1 by 2 root x. So power formula, n power x power n formula. And sin x, if you differentiate it is cos x if you differentiate it is sin minus sin x, tan x if you differentiate it is secant square x, cot x if you differentiate it is minus cosecant square x. Same way, when you differentiate secant x, it is secant x tan x. Same way, if you differentiate cosecant x, what will it come? It is minus cosecant x cot x. Then differentiation of sine inverse x is 1 by root of 1 minus x square. Then when you differentiate cos inverse of x, that will be minus 1 by root of 1 minus x square. Same way, when you differentiate tan inverse of x, it will be 1 by 1 plus x square. Same way, if you differentiate cot inverse of x, it will be minus 1 by 1 plus x square. Secant inverse is 1 by x into root of x square minus 1. This is minus 1 by x into root of x square minus 1. So like this it will be. Now parametric functions. So when you talk about the parametric functions, you are having dy by dx. So if your x is a function with respect to t and g is a function with respect to t. So here t is the parameter. How do? You have to differentiate the function with respect to t alone, because your y is in terms of t, your x is in terms of t. So it will be basically g dash of t and f dash of t. So basically you're differentiating it with respect to the parameter. Same way, if your function is respect to x and you have to find dy by dx, you have to differentiate with respect to the parameter. So dy by dx divided by dz by dx. So basically f dash of x into g dash of x. So this is the formula. So that's all. These are the main and basic things and basic formulas which you definitely have to know in chapter 5, which is differentiation and continuous functions. So yes, that's all. If you want certain other videos similar to this, please do comment below and we are ready to put. Okay, that's it. Bye.